Hello everyone, welcome to AB Max Solutions channel. In this video, we are going to see about derivatives of trigonometric functions. So trigonometry is all about triangles. So where do those come in? Let us consider a coordinate plane and draw a circle. Let's draw a radius and start to move it. So we can stop anywhere. And let's draw a line from the radius to down to the x-axis. It will be a right angle triangle. So the radius is hypotenuse, the base is the adjacent side, and the height is the opposite side. As this angle grows, the hypotenuse will always be the same, since it is the radius of the circle. But the length of legs changes depending on the angle. So to describe the precise relationship between these side lengths and this angle, we can use trigonometric functions. So we have three main functions in trigonometry. They are sine, cosine, and tangent. So the ratio of opposite side to hypotenuse gives the value of sine theta. Similarly, the ratio of adjacent to hypotenuse gives the value of cos theta. And the ratio of opposite side to the adjacent side, or sine theta to cos theta, gives the value of tan theta. So the reciprocal of sine theta is cosecant theta, the reciprocal of cos theta is secant theta, and the reciprocal of tan theta is cot theta. So this circle describes a unit circle. Every point on the circle has the coordinates cos theta, sine theta. So here x coordinate is cos theta and y coordinate is sine theta. So we know Pythagoras theorem as a square plus b square is equal to c square. So here let us consider the base value as a and the opposite side as b. So cos square theta plus sine square theta value is equal to 1. So the hypotenuse is equal to 1, which is the radius of the unit circle. So sine theta can have only the values with this interval 0, 1 to 0, -1. When we look at x values for these points, they will always fall between -1 to +1. So sine and cosine will have domain of all real numbers and range -1 to +1. So this is the trigonometric table. So sine 0 is equal to 0, sine 30 equal to 1 by 2, sine 45 is equal to 1 by root 2, sine 60 degree value is equal to root 3 by 2, and sine 90 degree value is equal to 1. So we have the values for cos theta, tan theta, cosecant theta, secant theta, cot theta. So this is the unit circle chart. So we know that every point on this unit circle has the coordinate cos theta, sine theta. Since we know the values for theta, let's substitute it. So when theta equal to 0 degree, cos 0, sine 0 equals, cos 0 is 1 and sine 0 is 0. So the coordinate is 1, 0. Similarly, when we substitute theta is equal to 30 degree, the value of cos 30 degree in radians it is pi by 6. So let us write it as cos pi by 6 and sine pi by 6. So cos 30 degree is nothing but root 3 by 2 and sine 30 degree is nothing but 1 by 2. So similarly, when we substitute these radians or when we substitute these degrees, we will get the coordinates. Let us consider f of x is equal to sin x. All multiples of pi by 2, that is sin n pi by 2 equals plus or minus 1. For example, sin pi by 2 equals 1, sin 3 pi by 2 equals -1. Similarly, sin pi by 2 equals 1 and sin 7 pi by 2 equals -1. And all multiples of n pi equals 0, where n is an integer. So sin pi equals 0 and and sine 2 pi equals 0, sine 3 pi equals 0, and it goes on. So sine n pi equals 0. So when we plot these points in a coordinate plane, we will get a curve. The shape of the curve repeats after 2 pi. So the sine function has values positive or negative depending upon the quadrants. Since values are positive between 0 and pi, which corresponds to the value of sine functions in quadrants 1 and 2, and negative between pi and 2 pi, which corresponds to the value of sine function in quadrants 3 and 4. So let us see for cosx. In cos, all multiples of pi equals -1 the whole power n, where n is any integer. So cos n pi equals 1 when n is even, and cos n pi equals -1 when n is odd. For example, cos pi equals -1 the whole power 1, which is -1, and cos 2 pi equals -1 the whole power 2, which is equal to +1. And cos n pi by 2 equals 0 when n is an odd integer. For example, cos pi by 2 equals 0, cos 3 pi by 2 equals 0, and it goes on. So the cosine graph is just like sine graph. The only difference between sine graph and cos graph is that the sine graph starts from 0 while the cos graph starts from pi by 2. So the period of cosine function is also 2 pi. When we look at the slope of tangent for sine curve, the change in x always equal to 1, since the radius of unit circle equals 1. So at x is equal to 0, the slope of tangent is equal to 1. And when x is equal to pi by 2, the slope equals -0.01. And when x is equal to pi, m is equal to -1, or slope of tangent is equal to -1. So when we plot the slope of tangent in different coordinate plane, we will get the cosine graph. So we know that the function has a maximum or minimum at a point where its derivative is 0. So we can observe that whenever sin x is maximum or minimum, cos x is 0 at all such points. So here it is maximum at x is equal to pi by 2 and minimum at x is equal to 3 pi by 2. Similarly, cos pi by 2 equals 0, cos 3 pi by 2 equals 0, and cos 5 pi by 2 equals 0. This way we can prove that the derivative of sin x is cos x graphically. So the derivative of sin x is equal to cos x. So when we look at the slope of tangent for the function cos x, as sin x is a periodic function, the graph of differentiation of cos x is also periodic and its period is 2 pi. So the function has 0 value at x is equal to 0 and minimum value of -1 at x is equal to pi by 2 and 5 pi by 2, and maximum value of 1 at x is equal to -2 pi by 2 and 3 pi by 2. So this is the curve of sin x, and this black curve denotes the curve of negative sin x, and we got the negative sin x curve. So the differentiation of cos x is negative sin x. So differentiation of sin x is equal to cos x, and differentiation of cos x is equal to negative sin x. I hope everyone understand how to differentiate sin x and cos x. Thank you for watching this video. Don't forget to subscribe my channel. Thank you.